Yeah, that's fun, right? I had everything perfectly set up except for one thing. That's all it takes sometimes. Hello and welcome to the show. It's me. I'm John Park. This is John Park's Workshop. You are you, and you are part of our Adafruit community, so we are really excited and happy to have you joining us here today. Hi to everyone over in the YouTube chat. I see you. Anthony Becerra says that they have put together their Macropad. Hey, that's cool. We're going to be talking about the Macropad today, in fact. I think the YouTube stream is catching up now because I'm seeing people saying no sound, but now sound. So sound is back. In fact, I even set up a little something that I'll show later with the Macropad to maybe help me with my muting and my unmuting. It'll work something like this. Oh, you know what? I don't have it plugged in right now. I'm not going to tempt fate. We'll do that later. Later. Let's see what else is going on. We've got some fun stuff planned. I'm going to talk about some job board stuff, some product pick of the week stuff. I've got a CircuitPython Parsec for you. What else? And Macropad things. And then I also taking a cue from the Ask an Engineer show. If you got any questions, we can do some Q&A either during the show throughout or at the end. If you got any questions, go ahead and post them over in our Discord chat or in YouTube. Those are the two I'm watching. So if you're watching on Twitch or Periscope or LinkedIn or one of those other great places, awesome. Facebook too. But I'm not watching the chat on those because I only have so much attention I can spare on different chats. So best place to go is to the Discord. It's at the adafruit.it/Discord. If you head to that URL, you'll get an invite. You can join in the Discord, and look, this is what it looks like. If you head to the live broadcast chat channel, in fact, let me show you this real quick. I'm gonna do a little adjustment here on the screen share and shoot that over there. There you can see that is what our channels look like there. So we have live broadcast chat. That's where you usually find people during a live broadcast. But then there's a whole slew of other channels that you can check out, especially these help channels are terrific. If you have help questions for any of these types of topics like CircuitPython, Arduino, 3D printing, audio, Raspberry Pi, and so on and so on. Those are great channels to go and check out. And it's I don't know, we have somewhere over 25,000 members, I believe, of our Discord, and there are people on there 24/7 answering questions, helping each other out, making each other laugh. So I encourage you to go check it out. And that's the Discord. So that's who I'm talking to over there. Hello, Dexter Starboard. Hey, Rich Sad. Hi, Doctor. Hello, Blitz City DIY. Nice to see you. Andy Calloway. Hello. I think I saw C. Grover. Hey, C. Grover. First question is in YouTube. Someone asks, any relation to the Park brothers of DC fame? I don't think so. I don't know who those Park brothers are, so I'm going to say no. Not. All right. So, next thing I'll mention is we've got our job board over at jobs.adafruit.com. So if you are looking for work, there are worse places you could go than heading over to jobs.adafruit.com. This is it right here. If you head to jobs.adafruit.com, it's a free job board. You can look for jobs there. You can post your resume if you're looking for work. Here are a few new positions up at the top here that might be interesting to people. I saw this one jumped out at me. CircuitPython coder needed for Adafruit Matrix portal. If we click that went up just yesterday. Someone is looking for help with doing a 64x32 LED matrix using the Matrix portal and CircuitPython, and they want to be able to show some finhub.io stock info and nomics.com crypto data. And they have some project examples they show. It's based on something that actually a good friend of mine, Mario Cruz, who is one of the people behind the Miami Maker Faire. It looks like he had a stock ticker project that's being referenced here. So really cool position. If someone's looking for some freelance work, that's a good place to check it out. And this person's looking for bids, so you can bid on how much you want to make to do that job. You probably want to get more details first, but that is just one position that is up right now on jobs.adafruit.com. So go check it out, won't you? And since I said I'm going to keep an eye out for question and answer on the Discord, I actually better do that occasionally. So I'm going to just check in on the Discord. Let's see. No questions so far. Good. We're safe. Okay, but Britt, I don't mean good. I mean, ask some questions. Maybe some easy ones at first. I don't know. All right, next up, look, it's sort of a show within a show. This is a recap that I like to do about my Tuesday show. So just 2 short days ago, right at this time, I was running my JP's Product Pick of the Week show. Every week I do a product pick on Tuesdays at 1 o'clock Pacific time, 4 o'clock Eastern time. About 15 minutes to half hour, and I'll go over a new product pick, show you a little demo, how to use it, and there's usually a deep discount on the product of the week during the live stream only. So that disappears after the live stream. There may be discounts at another time or coupon codes, but this one, this was 50% off on this week's product pick of the week. That is the product that I picked this week. It's the RP2040 QD Trinky, which is just a plug-in Trinky, and you can use it both as a CircuitPython device as well as with Blinka to use Python on your computer. And here is a little 1-minute recap. The Trinky QD 2040 is a USB key and a QD RP2040 all in one. I have a magnetometer plugged into it over the Stemma QT I2C. And then I'm going to go ahead and plug it into a hub that's plugged into my computer. I'm going to run Python code on the computer that is then using the USB connectivity of the Trinky to access the sensor here. So if I take a magnet and go ahead and move it towards and away from that little magnet sensor, you can see I have the values changing in the little terminal there, as well as the NeoPixel that's built onto the Trinky updating and increasing its brightness or decreasing its brightness. So that is one really cool way that you can use the Trinky, which is as a sort of go-between for your Python on your computer to talk to CircuitPython-based devices. It is the Trinky QD 2040. All right, yeah, so that was our product pick of the week, and you can still get them, I think. They were running low on stock the last I checked, but you can head on over to the product page and look and see if that's still available. Otherwise, hit the notify me link and you'll get an email as soon as they come back in stock. Let's see. The question I got over in YouTube is, JP, do you know if Adafruit are going to make the wireless NeoPixels? That is, I think you may be referring to the inductive charged or induction powered LEDs that Lady Ada showed recently. I do not know if we're going to carry those. Those are, I believe, single color. I'm not sure if those have a chip in them to do any multicolor stuff. They could, but those actually have a little inductive coil, just like a RFID tag, passive RFID tag does. And then there's a large coil, inductive coil, that charges it and lights up the LED when it's in a certain range. It's really cool. In fact, I think I've seen vests that you hide under your clothes that have a coil like that for use in certain types of illusions and magic tricks. So it's kind of a cool thing to see the raw parts of that. I hope we carry them. Yeah, that would be really cool. The doctor says over in Discord that those are single color, no chips. I don't know if there's a reason you couldn't. I don't know if the power consumption of the chip makes that a little harder to do. Maybe you could have a capacitor in there to store up some of that power before it lights it up. But anyway, those sometimes. So one thing that Lady Ada does a lot is source cool stuff. In fact, she is a really like ninja level at sourcing things from Chinese parts suppliers, and she gets in a lot of stuff to check out, and then some of that ends up in our store. Some of it ends up, for one reason or another, not going into the store. So In short, I don't know, but I hope so. Those look really cool. A lot of fun. Let's see. I think that was the only question I saw. Yeah. Okay, so let's see. Next up, we've got our CircuitPython Parsec. So get ready for this. All right, so let me get set up here. I think I've got it all set up. Yeah, okay. Looks good. For the CircuitPython Parsec today, I wanted to show how you can read a rotary encoder inside of CircuitPython. This is really straightforward thanks to our rotary I/O library. So if you look at what I have here, I'm using one of our Trinkies that's made for running a rotary encoder, but you could plug a rotary encoder into most any microcontroller. It just takes ground and 2 pins to read which direction it's being turned. There's little internal switches that open and close. In this case, this one's purpose-built for it. What we do in CircuitPython is we're importing the board, so we have some pin definitions, and we're importing rotary I/O library. Then with that rotary I/O library imported, we can do this. Encoder, which is the name I'm giving this, just easy to reference. The encoder, this is the encoder object, equals rotary IO.incremental encoder, and then we point to the 2 board pins. In this case, the board pins are named Rot A and Rot B, which is super convenient. Sometimes that'll just be a general purpose I/O pin or a digital pin. And that will set it up. It's going to work at this point. Everything else is just how do I want to use it. So I want to print out when it turns its position, and I only want to do that when I turn it so it's not constantly flooding. And that's why I have this variable here called last position, which is going to store the state of things. So it'll only update when it changes. Then this is the main loop of the program. While true, if encoder.position is not the last position. So encoder.position, that's all you have to ask for to find the value of what the encoder is doing, which way it's turning, and we can then compare that to that last position it was at, and then we know we're going to do the next thing if they've changed, which is print that encoder position, and then we update that state of the last position. So you can see here, as I turn this little knob here, that's turning that rotary encoder shaft, and that is being read by the little Trinky there. The microcontroller is noticing those changes on its 2 pins, the rotary A and rotary B pin, and then I'm printing out there that change. So you can use this for things like volume controllers, you can use this for things like MIDI CC, for mouse control, for moving a mouse on one axis. There's a lot of ways to use it, but it is dead simple to use, and that is all it takes to read a rotary encoder inside of CircuitPython using the rotary I/O library. And that is your CircuitPython Parsec. Tremendous. I love how easy that has become to use things like rotary encoders. There are, by the way, a lot of these rotary encoders, I didn't show this, but a lot of these rotary encoders have a second little secret up their sleeve, which is they have a push button. So let me move this one to camera view. So this one, you can actually click the knob down, and it has a button that's read just like any digital button, digital input button. So it's actually separate from rotary I/O. That library doesn't actually care about that. That's a separate set of pins that are being used over there. Let's see. What else? C. Grover says it's possible to preset the encoder position value. Oh, yeah. So if you're using it for something like a volume and you want to start at, when you boot this up, some preset, because these encoders are called sometimes endless encoders because they will spin forever in either direction. They don't have stops like a potentiometer does. So sometimes you don't want to start them at 0. So you can actually tell it, hey, your sort of relative starting position is going to be, in this case, let's say 12, and then when I turn to the right, one little notch will go up to 13. If we go left, we'll go to 11. So, also sometimes those directions are not what you would expect. So, depending on the board setup, the encoder may decrease as you turn clockwise and increase as you turn counterclockwise. It's easy to change that in code. In this case, this one's set up to work the way that I expect it. Although I'll show you. Let's jump back here for a second. This is a little experiment. I think with this one, if I just change the pin order, so if I say, let me increase the scale of that a little. You can see that better. So if I tell it to actually read pin B, wrote B first, and pin A, wrote A second, and then I'm going to hit save. This is going to resave my code to the board. And now when I turn this to the right, you can see it's going in the negative, so it's subtracting from the original position, and the positive is counterclockwise. Let's see, actually, I want to try what C. Grover said. You can do encoder.position equals. Okay, so we can give it a starting position. Let's do that. Encoder.position equals 12. I'm going to hit save. And now you'll see when I start turning it, it's moving from 12 as its starting point. I'll flip these back to the clockwise is positive setting. And now if you're using this, particularly if you're in something that has, let's say, some graphical levels and some software, and you're sending it either incremental arrow keys to bump a value up, that often works, or something like MIDI CC values. We can start at something, in this case we're starting at 12, and now we're going back down to 0, and we'll go below. You can also do things like set the range to clamp at certain points, so it never goes lower than a certain number, never goes higher than a certain number. That would all be in software. The encoder doesn't care, it's just going to keep turning. And you can remap those into different ranges. There's a lot of neat stuff you can do with your code once you have this basic thing working of reading your encoders. So I'm a big fan of these. And this one actually is I'm going to grab a Allen hex driver here. This knob here is, let me go to a bigger view for you. This knob is on here with a little set screw that clamps it to the D shaft. Do I have the right size? I don't think I have the right size Allen wrench. Oh, there we go. No? Hold on. Putting on glasses. Are you going to fit? No, that's too big. Hold on. This is a knob that Adafruit sells, by the way. Oh, I've disconnected it now. This is definitely not the right size either. Hold on. How did I get this on in the first place? I swear it was one of these. How about you? How about you? Aha. There we go. Sorry about that. Yeah, so that was a 2 millimeter socket. So these have usually have a little D shaft on them, and you can use either a D-shaped knob. These usually ship with a little soft touch rubber knob. Go into my bin of knobs. I don't have one of those in here, but you can see something like these little jog wheel knobs will work on those, and those have a little D-shaft shape. Here's something I pulled off of some old piece of equipment, and same thing, it has a little D-shaft there. So those will all slip onto there. So you can get some cool knobs onto there other than just that default. Usually, by the way, you don't want an indicator on these since they are endless. That indicator isn't very meaningful usually. So you'll usually see on encoders, on an endless encoder, you'll see no marking indicator versus something like a potentiometer that has stops on it, and then that means something. That means something here. Those indicators usually aren't useful. All right. So let's see. Let's get back to questions. I thought I saw another one. Stuart Riggs says, rotary encoders on Arduino was a process for me. Yeah, it's been a little while since I've done them, and I believe that there was a bit of a process for it, but usually there's a library that makes life easier with these things. What else? Oh, let me pop up the Discord here so you can follow along. Let me move that piece out of my face there. There we go. And good. All right. Oh yeah. So Toddbot said that since this is a metal knob, this is a metal knob here. You can do his CapSense hack, which we need to look at that. I need to try that out, and I'll show it on the show sometime. Toddbot came up with a way to use the metal knob on the metal shaft as a CapSense input, so that you can tell if you're touching the knob or not, and that's different from clicking it in the case of a push encoder, and it's different from turning it. And I don't know, Todd, tell us, did you do that with, I don't know what board you used. I know that this Trinky has CapSense here, so you could maybe run a wire from that to a part of the rotary encoder itself. I'm not sure if that's how you did that. How'd you do that? Clever, Todd. Excellent. All right, so let's get to the project of the week. Let me get this thing out of the way. So this is, I'd love to introduce our new Macropad. You may have seen us talking about it a bit. Oh, look, and there's one of those knobs I was talking about. So that's our kind of default soft touch knob that we put on there. So I'm going to show you it in action first and talk about the software. Then I'll take it apart and put it back together, since I wanted to start with this actually working, since I know it is right now. So let's start off with what is this thing? So this is an RP2040 chip on there, same as the Pico from Raspberry Pi. It's the Raspberry Pi chip. And this has a set of 12 mechanical key switches. So it has 12 pins on the RP2040 that are being used directly as digital inputs, which means we're not doing a scan matrix and we're not doing a shift register. It's just individual inputs. And they all have neopixels underneath them, so they can be individually addressed to do different color things. And that can be anything from just light them up a color, light each key a different color, change colors when you press them, have the colors change when you adjust the rotary encoder, or something else in your software needs to update you. But we also have this really great OLED screen on here, and that means that we can do, I think it's a 128 by 64, so we can do some pretty nice sharp display, especially of things like little text labels, which I'll show you. I'm working on that. And then it has the push encoder on there, a little rotary encoder with the clicky button. And that is about the shape of things. And so what I'm going to do is plug in, first of all, I've got a USB-C cable here, and I happen to have a little right angle connector on it, which I like for sending that cable off to the side. This is a cable that I just coiled earlier today. I didn't coil it super tight, but I coiled it over a brass tube, heated it up, and then chilled it with some upside down air duster canister, my old hack for that. So it's a long cable, and I just wanted it to be shorter and coilier, so now it is. And you can see now this thing's lit up. So let me give you a top-down view of that so you can see a little better what's going on. And let me put me off to the side there. There we go. So you can see here when this starts up, it gives me a little readout on the screen that says its name, Macropad PID. By the way, my camera setup is giving it a little bit of a flicker to the screen that you don't see in real life. So just so you know, it's not doing this on you all the time. It's actually sharp and still. So actually, since we just talked about rotary encoder, you can see here I've got a little readout on the screen there of my rotary encoder position. Starts at 0 when you start it up, and now we can adjust that. I have code in there, which I'm not using right now, that will adjust the volume. And I didn't want to be messing with this computer while I'm while I'm trying to do the show, because that can be a bad thing. So I actually commented out that as well as the mute. So when I press this button, it does the mute. It also, you can see, flashes the brights there. So all the LEDs, all those neopixels, have a brightness value of 0.1 out of a possible 1. And when I press this, it goes all the way up, cranks up to full 1 brightness. And then here on the side, all I've got is just a little set of labels, basically. That's telling me what do these keys do. I have them set up as a number pad right now. So if I want to use, let's say, a different camera, I can hit 4, 5, and 6. And those are just sending the HID keyboard command of 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And then I have star and asterisk, just like, or star and hashtag or pound, just like a phone keypad, basically. And those are just sending those as if I typed them on my keyboard. They do the exact same thing. So if I just hit 1 on my, let's say 4, 5, 6 on my regular keyboard, it's the same as 4, 5, 6 here. And the HID commands, they can be anything you want. If you're just using USB HID keyboard stuff, they can be a keystroke. They can also be keystroke combinations. So you could do Control-Alt-Delete if you wanted to. You can do copy-paste buttons that are actually a group of macros, which is why these are called Macropads a lot of the time. So sort of a little different than just a number pad, which usually has 1 or maybe 2 functions. It's usually either a 10-key number input with calculator buttons for plus, minus, divide, multiply. That's pretty typical. A lot of number pads either built onto your keyboard as a separate device will have a numlock button in the upper left corner that switches the function of some keys to be arrow keys and a few other things like page up, page down, I think. So that's usually the number pad. The macro pad is more of a, it can be anything you want type of thing. You could, for example, potentially code it so that it works in this sort of sideways orientation, and you might use something that requires 3 rows of 4 keys for however you want to use it. Maybe it's for gaming. If you have chains of commands that you want to send, we'll be doing some projects with that sort of idea in mind. I think I'm going to do a Minecraft cheat pad kind of thing for creative mode that does different types of macros and turbo things. You can also create layers of functionality with this. I think Phil B might be working on a macro pad for graphics software shortcuts, where you could just turn your knob and go between, okay, here's my shortcuts in Photoshop when I'm painting in Photoshop. Here's the shortcuts when I'm doing photo editing. Here's a set of Illustrator shortcuts. So you can do a lot with that I think it would be useful to update this little screen here to tell you what those are being used for. Doctor says they want to use this as a cyberdeck type of thing in a movie. Yeah, absolutely. It's definitely well suited for that. Let's see. The code for this, let me jump over to Adam and switch. We'll switch out. Actually, let's go to, where'd that view go? I have a convenient view set up for this. That one will work really well, yeah. Okay, so here in my text editor, this is the code I'm running right now on this, and a lot of this is in flux. So right now there are a few libraries I'm using to accomplish this, which I think we're planning to make some convenience, a convenience library for Macropad. Kattni's working on it right now, that will do some of the setup and things for you. It won't mean you can't do the same stuff. It'll just make some things a little easier to do. So mine, you can see I'm importing a ton of libraries right now. The key one here, pardon the pun, is keypad. So in fact, let me jump to my browser here for a second, and I'll show you a few things. First of all, here's this product. There's a couple of versions of it. It's out of stock right now, but you can sign up to be notified when it's back in stock. There's another version that is the bare bones kit, which is just the PCB pre-soldered, but you'll have to bring your own switches, bring your own keycaps, and bring your own mounting solutions, or you can buy a little extras kit we have that includes the plate that kind of keeps the keys locked in next to each other so they don't wobble, which can happen if you don't put that in, as well as this beautiful silk screen that Phil B did that goes on the back. And we'll take a closer look at that in a second when I take this apart. If you head to the main guide, which just came out yesterday from Kattni, this will go over the basics and how to use it in both CircuitPython and in Arduino. And one of the keys to this is this keypad and matrix scanning in CircuitPython library that Dan Halbert wrote. This is able to read individual GPIO pins like we're doing here, but it can also read a key matrix, a scan matrix. It's like a diode matrix with columns and rows, as well as a shift register setup that uses a shift register to check the different pins and the different keys. And so that's what I'm using, and I'll show you how that works, sort of the basics of it, and the specifics of how I'm using it in this project. So I won't go through this in excruciating detail, all of these things here, but the main thing here that I want to talk about is the setup for using the keys. So I've imported that keypad library. I've imported the board library. Since I've imported those two things, I can do this. I can set up this list of the different keys that I'm using, and I'm picking those in this order of, I think 1 is the upper left corner and 12 is the bottom right corner. And you'll notice those pins are not 0 indexed. These names of these objects, these board objects, have 1 indexed, which keeps it a little more in tune with the way a number pad or a macro pad works, or the way people think about it. And then I'm creating this keypad object. So we're calling it keys. This could be anything, could be called Macropad. But the keypad.keys is then being fed this list of the key pins. So these are the pins I'm using. So if you wanted to use this on something else, let's say you wanted to use it on a Cutie Pie, for example, or a featherboard, you would just feed it the list of the GPIO pins that you're using with buttons or keys attached to them. And then we're setting it to say, are we going high or low, or true or false when we press, and is it a pull up, which we're saying true, it's pull up resistor. So that again might vary depending on the type of board you're using it with. Then we do some stuff where I'm setting up some variables for colors. I'm setting up my HID, both keyboard and consumer control, which is stuff like mute and volume up, volume down. And then I've got this code that I keep recycling or slightly changing that I did first with, I think, the launch deck project I built using the Trellis M4, and then again with my Pico keyboard that I built. And now, again, what I'm doing here is I have this dictionary that includes 12 items in it, and then each of those have their own little set of data that I want, which is the color that I want the key to be, whether it's going to be a key press or a media control thing. In this case, they're all key, so they all say key there. And then what they do when they get pressed. So here you can see I've got 7, 8, 9, 4, 5, 6, 1, 2, 3, and then the Shift 8, which is the star, the 0, and then Shift 3, which is the hashtag. So we have some great guides about how to use HID keyboard commands and lists of what those are. And one thing you have to be aware of is that things aren't always named what you expect they're going to be named. So there is not a star or an asterisk or a pound or a hashtag. Instead, those are named for the shift function of some of the number keys in this case. If you wanted a capital A, you would do key code shift, comma, key code A. So that's how you're able to string things together, which means you can do big, huge key commands, Control, Alt, Shift, Delete, right arrow, all that's possible. Then I'm setting up the encoder just the same way I showed before, as well as doing the switch on it. Setting up the NeoPixels on here, and then setting up the display. And we'll do more stuff with the display as we're going to incorporate some display stuff into the library for the Macropad, so I won't go into it now. This is just using sort of our traditional display I/O for graphics. And then I'm setting up the title here and the text for the readout of the knob. And then I'm setting up this little set of variables for where I want to place these little labels, this little cheat sheet. And then I have this set of labeled data that, again, is kind of a dictionary of my what's being displayed, where it is on X, where it is on Y. By the way, thanks to our good friend ToddBot for helping me come up with a somewhat succinct way of doing that. So this runs through and sets up all of those rather than one at a time setting all those labels up, which is just makes things more efficient. Thank you, Todd. And then getting back to the meat of how Keypad works, this is the sort of key thing, event. It is event-based, and event equals the keys event get. So this is part of Dan Halbert's Keypad library. It goes and it just sweeps through and checks either the matrix, the shift register, or in this case, just all of those pins, all 12 of those pins, and says, has anything changed? If nothing has changed, that means nothing's being pressed, then I'm going to go ahead and do all this stuff with the encoder, from changing its value on there to changing the brightness. So all of that encoder code is happening when no keys are pressed, including using the debouncer for checking the switch. When that switch falls, you can see here, right now I'm just printing the word mute. Let me go ahead and show you my serial output here. So you can see it's changing that value as well as printing volume up or volume down. I'm just doing those right now instead of having those actually change my volume or my mute. But these are the codes, these are the commands that I commented out, so we're not doing those right now. Volume increment, volume decrement, and mute. And then the actual reading of the keys is kind of the main event right here. Again, pardon the pun, num equals event.keynumber. So event returns which key number has had something happen. And then if that event is it being pressed, we do one thing. And if that event is it being released, we do a different thing. So what I'm doing here is keyboard.press, and then going up and checking my little dictionary there to see which thing for the currently pressed key happens. So I'll place my cursor here, and I'm going to press the bottom right key, which, as we can see from the little legend, is the hashtag there. So that's a comment. So that's kind of a safe thing. Now I can go through and start typing stuff. And you'll also notice this has key repeat because we're using the HID key command of press rather than the HID key command of send. So send, I actually am using that with my mute, CC send. That sends a one-time thing when it gets pressed and doesn't really care if it's been released or not, but that means you can't kind of hang on that and spam that button. With the press and release, it will, which is great for things where you do want to have a key repeat happening. And let me delete that out of there. I don't need those. Then I'm also printing the name of whatever I've done down here in my serial port. So you can see not only is the event returning its thing, which is this print event. So that's kind of what the library, the Keypad library knows is, okay, event key number 9 was pressed or released, which is nice for debugging. I won't need those in the end. Probably don't need these print statements here either. But I may end up using that for some stuff on the screen. So it may be nice to highlight a character when it is being pressed, or just show you a little printout of what you've typed in there, almost like a ledger and a calculator type of thing. And you can also see when I press a key, I am changing the pixel to red. So here you can see that goes red when it's get pressed, and then it goes back to its default color when it's released. And that default is taken again from this dictionary, key map, whichever item in that dictionary it is, and then the 0 item within that little sub list, which is the color. And then I show the pixels, so that's the NeoPixel since they're not set to auto show. And then I have a little debounce here that I probably don't even need because I'm printing and lighting up neopixels, which means that there's probably not a huge chance of needing it. I believe these are automatically debounced internally. In fact, let's shut this off and see if I'm right. We should be. Yeah, it behaves as expected. Let's see, does this stuff? Yep. Yeah, so I don't need that. In fact, we probably don't need time in here at all, unless you decide to start doing some other things like counting elapsed milliseconds to do some light show stuff, that kind of thing. So that was a lot. Let's see. Are there questions? Encoder can be used to set different profiles for different programs and uses, says Doctor. Absolutely. That's, I think, a really cool idea. It gives you a lot of versatility. In fact, if you look at the project that I was working on last week using my keypad as a modal MIDI keyboard, I don't have a rotary encoder or a screen on there. I don't even have neopixels. So everything I do is kind of key combos on startup or when it's running to send MIDI padding. This instead allows you to do, in fact, I think I'm gonna rewrite that a version of that for this so that I can pick scales and keys from the screen using the encoder. The question is, does the key repeat use the same delay frequency of the OS settings? Yes, I am 99% sure that is the case because there's nothing in this code, and I don't think there's anything in the library for HID. It is just simply sending the press HID command or message, and then the operating system is doing with that what it wants. And so your operating system key repeat should be what we're seeing there. So yeah, same as pressing a regular keyboard. Interestingly, in some cases with regular keyboards, particularly older keyboards that might have an LED underneath the caps lock and maybe the scroll lock and maybe escape, those LEDs are actually not driven by the microcontroller inside the keyboard. It's actually a message coming back from the computer. So if you're ever fooling around with an old keyboard and you're trying to set like a PS2 keyboard and you're trying to get the lights on it to light up, they won't until you have either a microcontroller or your computer on the other end sending a command back telling it to do the thing, which is kind of interesting. Let's see. Any other questions? No. Okay, so let's jump over here to the bench, and I will pull this apart for you so you can see how it goes together, and also take a look at the beautiful parts on here. Let's see. We have about 15 minutes, so I think we're good on time. Let's do a bit of a zoom in here. Set that there where you can see it. And move some stuff out of the way. So first of all, the keycaps, you're going to pry these off. This is one of these little whisk-looking egg beater type of keycap pullers. These are really nice because they slip in a pretty thin space, and then you just twist them to grab the corners of the key switch. Sometimes you can just get your finger up under there. It depends on the case that you have. So with these, you can get the two outer ones from the sides and then get that middle one. So you don't really need that. But with a more traditional keyboard that has a top enclosure, sometimes you need this sort of thing to get in there. Now, these are, these are Cherry MX compatible switches from Kale. These are called box reds, and they are linear key switches. These are the ones that come with our starter kit version of this that comes with all the parts. So that's what you'll get. But you can pop different key caps in there. In order to do that, what we'll do is we're actually going to pry up all of these keys because of the way the plate works. They've all been pressed into that plate and then into the sockets. And you just want to be a little careful that you don't bend them. So that's all it took there. And now you can see we've got our key switches there. These then pop out of here. So again, you don't want to bend the little legs on them. But that's what that'll look like when you start. I don't think I have any other key switches laying around here right now. They're all in my studio. But the plate there isn't strictly necessary. If you place that on and press it in there, it works. It's fairly stable. If you hit it at an angle, you can start to bump it up, which is what this plate is about. The plate is there to keep these sort of connected to each other mechanically so they don't move as much. But that right there will work just the same as not having that. In fact, let me plug this into some power so you can see. I say that, but let's actually find a cable long enough. In fact, let me go grab a longer woven cable from over here. So these are these new, whoops. I just tried to sabotage my microphone. Hopefully that's still working. Yeah, it's still working. So this is the new cable that one of the new cables that we sell. It's a USB-A on one side and USB-C on the other. And it's nice and long. So I'm just going to plug this into power. Sometimes USB-based stuff doesn't really run right when you just plug it into power and not a computer, but this should light up at least. Yeah, actually it's failing. So it's getting to a part where USB won't initialize because this is not on an actual computer. But you can see there that light is blinking there. There's like a little, let's see, I'm going to reset this with this side button. See that? That's blinking to tell me there's a problem. And the code only gets this far, and then it says, hey, USB HID is busy. I can't connect to anything. But yeah, all of this will run. And in fact, all these key switches are doing is shorting those two pins. So there's a data pin and a ground pin that are getting shorted to each other. So you could grab a wire and do like this, and that's the same as pressing any of those keys. So you got your keycaps, you got your plate here to hold the key switches next to each other. We have these socketed Kale sockets for the key switches, and then we have these underlit NeoPixels. So they're mounted on the reverse side, but pointing up through those holes. And then we got our little display in our encoder. So then this back plate, this is just a sort of a case to keep things flat. So you can put it on a desk, and we got a set of bumpers on there, little bump-ons. And these are some surface mount threaded bosses that you can screw into with a M3 screw. So that comes soldered on there. These are actually pick and placeable, solderable things. And then this is this beautiful decorative plate that you will never see unless you mount it backwards like that, which you have the option to mount it either way you like, that Phil B did. Devise your own paths. And there you can see, there's the board. So here is the RP2040 right there with the little Raspberry Pi logo on it. You might be able to see. Here's the connector for the display and the little ribbon cable. USB-C here. There's a little speaker there. So we're working on, Kattni's working on code, in fact, to be able to use that speaker with the library, with the new Macropad library that's coming out. And then here's this reset button. There's also a Stemma QT port right there that you'll be able to use to plug in any of our sensors or external things. So that is the main way you'll connect other stuff to this, because it doesn't have GPIO pins available with a header or anything like that. So that is the one way that you'll connect to sort of the outside world of sensors and devices. Oh, I think that was hidden. Sorry, that was hidden under a camera view I wasn't paying attention to. Sorry about that. Yeah, so that's Phil's back plate there, which is beautiful. And then lastly, I don't know if I mentioned this before, but the boot button is one and the same with that rotary encoder switch. So when you want to put new firmware on this, you hold boot, you press reset, you release reset, you release boot, and then it'll go into the boot loader drive where you can load on firmware. After that process, once it's booted up, once the code is running, then this can be used as a general purpose I/O switch. And I think that's it. So let's put it back together. And sorry, I can't see questions from here very well, so if there were questions about this while it's open, let me run over there real quick before I fully assemble this, just to see. Doctor says Macropad lets you do everything Daft Punk style. Yeah, a soundboard would be terrific. Work it. Harder. Let's see. Hello from the School of Cosplay in Vegas, says Gamer versus Taylor. We're going to be integrating Adafruit into our lessons later this year. Thank you so much for this. Oh, that's great. Very cool. Thanks for letting us know. I love the sound of that. School of Cosplay. That's fantastic. Beata Graf of Dalhagen says, yeah, the pins on those key switches are kind of weak. They are very thin. They are very weak. They're just an extension of the thin little metal inside the switch. So yeah, they're super easy to bend. You do want to be careful putting those back in. In fact, let me go put these back in over here and show you this process. So I think there may be a couple of ways to do this, but the way that the two ways that I've tried and succeeded with somewhat equally is just place them all in the switch plate first, like this, and then check very carefully that none of them are bent, and straighten them if they are. This, especially if you're grabbing a handful of switches out of a drawer or something like that. You want to make sure those are not bent. And then you're just going to very carefully place the whole thing like that and double and triple check from the side that everyone looks like they're lined up properly, and then just start squeezing that down. And as you do that, you just want to keep an eye. The other way to do it is to just place one switch in through the plate and then another from the corner and work your way around. But then you're both clicking them through the plate and into their little sockets. So I think this is looking pretty good. And then really you don't know if there's a bent pin there until you plug this into your computer and try it. That's really hard to see a bent pin in there. Luckily, if you're careful, you can unbend them. You can pull it out and unbend it. In fact, this one I did that. There's one leg on here that got bent that I had to take it out and straighten it with some needle nose pliers. So it's definitely possible. So let's jump back over here for a second and see if we succeeded. And there's a few ways we'll know. One is just if the LEDs change color. If they change to red, that means that it knows I've pressed them, just because that's what my code does. So yay, that'll work. And then I'll double check over here in my serial output and just by typing in USB that it's registering 7, 8, 9, 4, 5, 6, 1, 2, 3, star, 0, and pound. So all that's working. Hooray. So that's about it. That's how it works. Let me know if you have any other questions. We're just about out of time. Thanks for stopping in for today for a fun look at this new Macropad. And now I'm going to get to work on some projects with it. So I've already got kind of a cool camera switcher out of the bargain here. But I'm gonna work on porting my code over for the MIDI modal music stuff and change that a little bit. I just saw a question come through. Oh wow, I've got to scroll down. There's a bunch of questions. Am I going to go blind from direct exposure to neopixels? It's possible. These are bright. The keycaps help a little to diffuse it. And where do you order the board for your Pico keyboard? I did not see it on OshPark. Oh, I might not have shared it on OshPark. I thought I had, but I will. Thanks, Stuart. I will check. Oh, in fact, let me bring up Discord as I go through these questions. Let's go to the Chrome for a second here. Stuart's referring to this guide. Let's go Pico mechanical keyboard with fritzing. So you could upload, in this I tell you, I give you the Gerber file that you would need, or the zip file of Gerbers you would need to send it to OshPark, or JLC PCB is the place where I had it made at both of them. But under ordering PCBs, there's the Gerber. Yeah. Okay, I guess I didn't share it on OshPark. I thought I had. I'll share it on OshPark and put a link there. But you could upload it if you want to. And let's see. Can we send you letters and or packages? I don't have a P.O. box, but I've been thinking about getting one, Doctor. So if I do, I will post, because I'm happy to do viewer mail, show off stickers, what have you. So local beers, I don't know. But yeah, I'll be setting something up, because I've gotten that question before, and that would be loads of fun and free stuff, right? So why not? Oh, Doctor has a nice, let me throw the Discord back on here. Doctor has a nice DIY version of the keypad going, using 3 of the 1x4s. So that's excellent. All right, good. Well, I think that's about it. Question over in YouTube from Hendrik Potgeiter says, hi from South Africa. Have you got anything with LiDAR, and do you ship to South Africa? I do not know if we ship to South Africa. I believe we have one LiDAR. We have this. There's a few things calling themselves LiDAR. I think of this SlamTech if you're talking about like the, I think that's the rotating rangefinder type that you put on an autonomous vehicle. So we do have a few LiDAR things. So if you go to Adafruit and look for LiDAR, you should see it there. As far as where we ship, boy, that's an excellent question. I'm trying to think where we have that info. Let me check on shipping and returns. Overseas military, shipping options, international orders. We do DHL Express worldwide to Canada, Europe. Yeah, we do. It says all other international locations. So the only question mark I think with that is sometimes if an item is considered to be restricted for certain countries. So I don't know. But you could certainly ask in the either support@adafruit.com email address, or go to the forums and ask, and we should be able to help you out. Or if anyone knows in the chat, if anyone's ordered items to South Africa, please let me know. And that's about it. I think that's going to do it. So thank you, everyone, so much for stopping by to play around with this with me. Super fun. And I can't wait to see the kinds of projects people are going to do once they get their own. So sign up now. I think we had about 100 that we shipped, and we'll be making more. So stay tuned so you can get your own. All right, thanks everyone, and I will see you next Tuesday with a product pick of the week, and next Thursday with a new John Parks workshop. Bye-bye.